Okay, here I am back with the Guider 2. It appears I'm not the only one having problems with these. I posted a video a few days ago about how I level the magnetic bed by using paper shims. So I work out where the troughs and peaks are in the bed, and I cut shims to fit between the top part of the magnetic bed and the underside. It's quite difficult to see in here at the moment, but it's a series of shims with holes cut in them that correct for the undulations in the bed. But I was asked how I go about figuring out what shape the shims should be, and essentially what I do is I use a dial gauge. So basically I use one of these, and to fit it to the head I made a small dovetail out of a piece of brass. So the way I use this is I take the dial gauge and it slots into this dovetail. I can get in there with the camera in the way. It goes all the way to the bottom. I made it come in from the top in case I accidentally raise the bed too high, and that way I won't damage the gauge or anything else if I run into it with the bed. What I then do is use the manual mode on this machine to raise the platform, and then initially I level it at the points using the positions above each screw. Now this is another example of very poor design in this machine. These are just manual control buttons, and you'd expect them to do the same thing every time you press them, but they don't. The machine seems to have a mind of its own, so when you're trying to raise it, you do have to be really careful, because it doesn't do the same thing every time you press the buttons. Sometimes it will just bump up by a small amount, and other times it will raise by several millimeters. But once you've got the hang of that, what I do is I raise the bed until the gauge starts working. So as you saw there, it went way too far. So once I've got the bed in the position that's suitable for the dial gauge to give sensible readings, what I can then do is translate the head across the bed. So what I'll do is I'll just get the bed raised into the correct position and leveled, and then I'll come back and show you how I take the readings. Okay, so I have the bed raised and leveled, and what I now do is use the grid pattern on the bed to position the head in various locations, and then in each of those locations I take a reading. So I'll take a reading there. Now if you do try this, try and get a dial gauge that has a resolution of 0.1 millimeters. On this one, the full scale, as a complete revolution, is 0.1 millimeters. So what I tend to do with this is I count the number of revolutions, and I use those as fraction of a millimeter. So in other words, if I now start to move this, I'll bring it forward. So that's now 0.05 millimeters, and clockwise is the bed coming up, anti-clockwise is the bed going down. So in other words, this spot is now 0.05 millimeters lower. What I'm aiming for is about 0.1 millimeters across the entire bed, simply because that's the thickness of the sheets of paper that I'm using to make the shim, so I can't really get it any better than that. So I go to each position in turn, take a reading, and like I said, what I'm aiming for is less than a full revolution from centre out to each edge of the bed. So I've actually done that with this bed already. It did take quite a number of shims, but it's now within 0.1 across the entire bed. It actually took 7 shims, which obviously is quite a lot, and is way outside what you could print on without making these corrections. Okay, so once I have the machine set up and ready to take readings, what I now do is I've created a spreadsheet that I use to enter the readings into. So it looks like a bit of a mess, but this is a surface graph And what I do is enter the values I get from the dial gauge in this top table, and notice that some of the readings may be negative. That shows up on this graph where you have a plus and minus section, but I wanted to normalize it, so I included an offset. So all I do is I enter into here a value equivalent to the biggest negative value that I see in the readings. So in this case it's 0.1. And what that does in the bottom table is it normalizes all the results and makes all the results positive from 0 upwards. And then what we end up with is a surface plot that indicates the errors that are on the bed. So if I just manipulate this, I'll enter 0.5 in this 0.5. You can see that shows up very clearly. What you're aiming for, of course, is to get this as level as possible. It might take a few passes, but it will essentially give you the idea as to how to cut the shims and what shape they should be. So, using the colour codes I have here, anything below this band requires a shim. You can then look at it vertical from the top, and that will give you the profile of the shim that you need to cut out. As I say, you might need to go through it several times because it will take more than one shim, and unfortunately the beds, or at least the ones I've had to level, are not uniform in their distortion. They tend to have all sorts of weird and wonderful bumps and lumps in them, so it can take a bit of time to get it sorted out. Having said that, it's not too bad, usually half an hour, and I can get a new bed levelled and compensated for its unevenness. And it does make a huge difference. Trying to print on a bed that has 0.6, 0.7 difference from the centre to the edge is pretty much impossible, because that's several layer thicknesses in the print. But this method works really well. It's also a really good method for levelling the bed. I tend not to use the inbuilt levelling system. It doesn't really work very well. The sensor, there's a small sensor in here that's on a little remote control car servo, and it doesn't position in the same location each time it pops down. And that means that as you move around to do the levelling for the bed, you get all sorts of random behaviour, and it just doesn't work. So once I've done this and got the bed fundamentally level and even, what I do is I create a drawing of a perimeter. So essentially it's just a square hoop that's 0.5 millimetre high, and I start printing that, and then you can watch the print and you can see very clearly as the head moves around, especially if you use a brim or a skirt. You can see as it's running if it's properly levelled, and make any very fine adjustments that you need to finish off the levelling. And doing it that way, you get the bed very flat and very level. The only thing, as I mentioned in a previous video, is that this machine changes shape a lot during its warm-up period, and so you need to avoid chasing yourself around in circles. Give it an hour at least to warm up with the bed preheated to 60 degrees or so. I also actually blow a hot air gun into it for 2 or 3 minutes before I start it up. If you do that, be careful, there are bits in here that will melt fairly easily if you get close to them. Once I've done that, you start printing, and it's usually fairly good, and you can print a very large area models without too much difficulty. But if you try and use the inbuilt levelling, or if you don't level the bed and make it even, then you will get all sorts of problems. And if you're not familiar with 3D printing, you'll probably assume that you're doing things wrong, and chances are you're doing the right thing. And at some point the machine will start printing as it should. You'll naturally assume that the last thing you tried is what fixed it, and then you'll be confused next time you try to do that as to why that fix doesn't work again. and chances are it's because that's not what fixed it in the first place. So just give it plenty of time to warm up. I'm hoping the manufacturers will fix this. In the meantime, we'll just have to muddle through and try to make it work ourselves. If you do have any advice for me or for anyone else that might watch this video, then please put it in the comments.